I think I have that up now. Let me just go to slideshow. So I did some looking at the impact of copper and a few other micronutrients on protecting against people getting COVID-19. There are a couple of key points that I want to go over to start with. Copper may, it looks like, help individuals who've been exposed to COVID-19 fight off the infection. It's been shown to attack the outer shell of the virus as well as the connective foot and decreases infectiveness within 2 minutes in a norovirus strand. Copper absorption research has also shown that levels of copper absorption remain the same after 2.5 milligrams, so there isn't generally a point in consuming more than that. Okay. Nutrients which are, Copper is one of the nutrients which are critical to the maintenance of the immune system's normal activity, including avoiding and defeating infections. The European Food and Safety Authority has evaluated and deemed a total of 6 vitamins and 4 minerals, including copper, to be essential for the normal function of the immune system due to the scientific evidence that they've collected at the point that the study was done in 2020. Which raises the question of how low the vitamins and minerals would have to be to see a decrease in immune function. Many individuals in industrialized countries and non-industrialized countries often don't get enough of the micronutrients from their diet. And Galmez in 2020 specifically found widespread suboptimal intakes of these micronutrients in Europe, including copper, with a range of 11% to 30%, including a high prevalence of insufficient intake in the elderly. Low copper intake, even without reaching critical deficiency, is also associated with decreased T cell proliferation and abnormalities in immune cellular functioning. So your immune system is actively handicapped by having less copper. The European countries worst hit by the pandemic show population percents with suboptimal intake of vitamins and minerals that are important to the immune system. And a lower population percentage with covered needs of vitamin C, iron, and copper is related to higher relative mortality rates from COVID-19. The UK specifically presents with a large population percentage with suboptimal intake for these 3 micronutrients. So supporting immune function may help. Copper's been shown in the past to attack multiple different types of viruses, and there was actually a specific study done showing that it did work to a certain extent as a surface on COVID. Copper also appears to have a beneficial effect on the immune system. Copper's previously been implicated in the regulation of immune responses. Aside from decreasing the microbial burden itself, copper also appears to have an antimicrobial effect on its surroundings, and one which has been tested and remained consistent for 21 months. In that specific study, they actually found that there was a 64% decrease in microbial burden between pre-intervention and intervention phases in the control room. Having copper in the active rooms actually decreased the microbial burden in the entire environment, including the rooms that it wasn't in. The antimicrobial activity of the copper surfaces was also equivalent throughout the course of the trial, so the 21 months. So it stays effective for at least 21 months. We don't know an outside edge at this point. Historically, copper's been used in medicine for a long time. It was used for purification of drinking water and for burns in Egypt in 2000 BC. continued through Greece in 400 BC to early American pioneers who would actually place copper coins in water casks, and in World War II, where Japanese soldiers used pieces of copper in water bottles to prevent dysentery. It's also continued to be used for purification of water, including use in hospitals to prevent Legionnaire's disease to this day. It was used by Greeks in 400 BC for pulmonary diseases as well, and repeatedly in the 18th century when it became widely used clinically for both lung and mental issues. The Roman Empire used cooking utensils made from copper to prevent disease spread, and skin conditions were treated using copper oxide as well as malachite by the Aztecs. In some areas of Africa and Asia, copper sulfate is still used. Copper also has EPA approval for use as an antimicrobial surface. So there's a long history of use for related purposes. Copper ions directly attack viruses in two different ways using two different types of ions. Copper-2 attacks the capsid barrier, the shell around the virus, and then starts with the virus receptor sites, the foot that allows it to attack, immediately limiting its ability to infect individuals even prior to the virus's death, and is shown to decrease infection within 2 minutes in a norovirus strand. In 1993, research by Sagrapanti et al. Showed that after 30 minutes, 99% of the virus was inactivated in vitro. So 2 minutes is fairly quick, 30 minutes is a little bit longer, but it is actively working within 2 minutes and mostly has killed everything by 30. Copper-2 can also inhibit RNA polymerase activity by more than 60%, with copper exhibiting the strongest effect compared to other metal ions. And enveloped viruses are more strongly affected by copper-2 inactivation, and that RNA and lipids may increase sensitivity of viral particles to this inactivation. Basically, the copper actively attacks the RNA chains making up the virus, so it can't mutate. It's very, very dead. Copper-1 actually goes after the genome more completely. One of the nucleic acids forms covalent bonds with the copper, and in the process, it divides the genome into smaller and smaller pieces. It can occur as often as every 3 nucleotides, so you wind up with very, very small pieces of RNA by the end of it. It should be noted that copper can bind to other things instead, so you want to make sure that any individuals using this protocol are basically keeping an eye on that. This has been seen to start within 15 minutes and leaves no viable virus within 2 hours. The damage to viral DNA and RNA also means, as I said, that the information, the genomic information, will not be available for other viruses to integrate and mutate. And the DNA damage still occurs with nanoparticles of copper, not just with solid objects, which does suggest that it works internally as well. It's very important to remember that other, like I said, stronger bonds can distract the copper molecules, so glutathione and cysteine are things to be careful with. So there are multiple steps in immune function. The physical and biochemical barriers to entry, such as your skin and mucous membranes, innate immunity, T cells and B cells, and production of antibodies. Copper actually has an impact on pretty much every stage. The physical and biochemical barriers are the least obvious impact, but it does have an impact on the proper formation and function of connective tissues and collagen maturation. So it actually does have an impact on basically skin elasticity. Inflammatory processes involving different types of immune cells and antimicrobial substances in blood serum response. And copper also has intrinsic antimicrobial properties that destroy a wide range of microorganisms. So it potentially could decrease the overall burden on the immune system as well as going after COVID specifically. Immune cells also go to the infected area, eat up the infective cells, and explode, and clear up the particles released through the explosion. This process also produces a burst of O2, both as a signal and an attack, which then gets turned into hydrogen peroxide by copper. It's a lovely cycle, so that it can continue providing immune support without hurting the body. Copper helps with differentiation and proliferation of T lymphocytes, a subcategory of T cells, and also plays a role in the signal that activates T cells as well as T cell proliferation. Copper is also involved in the production of antibodies, which neutralize the invading agent and draw phagocytes to the area. Copper can trigger also both apoptosis and autophagy, both of which protect cells. And copper deficiency can even lead to, quote, increased viral virulence. That study was also done in 2020, and a less effective immune response against infections. And consistent with this evidence, it's been hypothesized that the optimal state of plasma copper levels can increase both innate and adaptive immunity, even exerting an effect as a preventative and therapeutic factor against COVID-19. You also see changes in copper amounts as a mark of an infection, regardless of the type. There's an increase in copper in serum if you have an infection. It's likely due to an increase in seroplasmin levels in the blood as a direct reaction to inflammation, and an increase in IL-6 levels has also been shown to increase the amount of seroplasmin in the blood. Since one molecule of seroplasmin binds 6 atoms of copper, even a modest increase in seroplasmin during infection can account for a substantial elevation in serum copper. It should be noted that while there are potential absorption issues in some people, often genetically, most of the time, if you don't have a way to bind copper, your body's not going to absorb it. It's fairly protective in that particular way. An increase in copper may be an attempt to decrease inflammation, and inflammatory diseases may be due to an insufficient anti-inflammatory response due to low levels of stored copper. We are seeing that a lot of people aren't getting enough copper in their diet, so there may be a link with an increase in inflammation. In contrast, studies analyzing copper absorption have shown that levels of copper absorption remain the same after the 2.5 milligrams. I did mention this at the beginning, but it's important, at least in the US, to repeat. People often like to assume that more is better, and it really isn't in this case. So I have some references, and does anyone have any questions?